Algebra 2 Honors, Conics Day 5, Translating Conics. We are going to be shifting the center of the ellipse and the hyperbola, and we have a few examples on that, and then you've got some homework on it. The first example is the circle, which we've already shifted, so it's just a review. Center here is at 2, -3. Radius is going to be 3. And so we go the right 2, down 3, and up 3, right 3, left 3, and down 3. And then we can sketch our circle. For the parabola, these equations are a little different than what we had studied when we were in the parabola section, but they are equivalent. This first one is equivalent if you would have x equals, and then we have 1 over 4p quantity y minus k squared and plus h. And that's the formula that we had in the parabola section. However, this formula is the one that I've always seen in other textbooks. So you could see it both ways. And so this next equation, if you would solve it for y, you would get y is equal to 1 over 4p x minus h squared plus k. And so those are the formulas that we're familiar with. All right, so that's the ellipse and the hyperbola. Notice in the numerators that instead of just x squared and y squared, you get x minus h quantity squared, y minus k squared. And you have to just be a little bit careful on this one because the center of the hyperbola is hk, but visually then notice h is on the right, k is on the left. It's whatever is with the x is going to be your h and the first coordinate of your center, and whatever is with the y is going to be your y coordinate of your center. So just be careful visually there. So in this first example, it's not in the form we used. If I go ahead and divide by 12, and then I'm going to put y on the left, if I subtract 2, there we have it in the form that we were using. And so this is a parabola. It's x squared. The p-value is positive because 12 is positive. So it is going to be a parabola opening up. And the vertex of that parabola is at 1, -2. So we go to graph that to the right 1 and down 2. There's your vertex. And the value of 4p is 12 because this is 1 over 4p. So 4p is 12, p is 3. And the distance from the oops, I put that as a vertex. The distance from the focus to the vertex, that distance is p units. And because we know it's opening up, because p is positive and it's an x squared, then I can take that vertex and I need to go straight up p units. So I add 3 to -2 and expect it to be at 1, 1. I can also just go on the graph. I'm going to go from this vertex, I'm going to go straight up 3 units because the value of p is 3. Oops. And so here is my focus, here is my vertex. P units on the other side is your directrix, and you're going to have a horizontal directrix. So if I go 3 units down on the other side, which since the vertex is already down 2, the directrix is going to be down 3 more than that. So down at -5, we have our directrix at y equals -5. Now, you need to find the points A and B, the endpoints of the focal chord. And the focal chord length is the 4p. And the focus is the midpoint of that. So from the focus, you go a length of 2p to the right and a length of, 2p to the left. And so 2p is 6, the whole length is 12, the focus is the midpoint, so 6 units to the right, and 6 units to the left. And those are your A and your B, and I want to see those, and I want your focus plotted on your parabolas. A lot of people didn't do that the first time around. So make sure that you've got those there. And so, again, from the focus, oops, that's not what I wanted to do. From the focus, you are going right 6 and left 6. So you're adding 6 to the x-coordinate, and you are subtracting 6 from the x-coordinate to get the endpoints. And then have your parabola go through A and B. All right, the next example, it's a hyperbola because we have the subtraction here. Whoops. And since we are subtracting y squared, that's how I know it's opening to the right or the left. You just have to memorize it. However you memorize it. I know when it's the y squared term's negative, that it opens right and left. And that means we are going to have a horizontal transverse axis. And the positive squared term, the value underneath that is always your a squared on a hyperbola. So a is 2. And so the length of the transverse axis is 4. The distance between the two vertices is 2a. It is of length 4. And so I'm going to go to the center, and the center is -2, 1. So to the left, -2 and up 1. And I need to go a units to the right and a units to the left to get to my vertices. So my vertices are a -2 plus or minus 2, 1, but you can't leave them like that. You need to simplify, and you get a 0, 1, and a -4, 1. You go a units to the right and left. A is 2. So here's a vertice, and here is a vertice. Those are those 0, 1, and -4, 1. Those are my vertices of my hyperbola. But I also need to, other points on the box, you need to draw the box. And the vertices are on the box, and the other points on the box go up and down B units from the center. And so the center is -2, and we're going to go up or down B units, and B squared is 9, so B is 3. So the other points on their box are -2, 4, and -2, -2. So from the center, you're going to go up 3 units and down 3 units. And those are the other points on the box. And then we're going to dash our box. And then we can put our asymptotes through the corners and through the center and dash those. And from here, I need the equations of the asymptotes. And since the center is at -2, 1, it's going to be y minus 1 equals plus or minus. For the slope, whatever is underneath the y coordinate, the square root of that is my rise. And then whatever is underneath my x coordinate, the square root of that is my run. And then we had that change. It's going to be x plus 2. Notice how this x plus 2 matches that, and the y minus 1 matches over here. Now, they will probably take that equation and write it in y equals mx plus b form, and you have to do it twice because there's two lines. Once for a positive 3/2 and once for a negative 3/2 in order to check your answers, because I think the textbook puts them in this order, but I prefer this. And that's what I would like to see on the test. It just changed the form in order to correct that. Now, we're still missing foci, and we need to sketch this. And the foci involve C. They're C units, in this case, from the center, they have to be on the same line as the transverse axis. So from the center, we're going to go to the right C units and to the left C units. And in a hyperbola, a squared plus b squared equals c squared. That is the relationship between a, b, and c. And so we have that a squared is 4, b squared is 9. It's the sum of those two values in the denominator equals c squared. So c is the square root of 13. And the square root of 13, approximately, say, 3.7. So from the center, you're going 3.7 to the right and 3.7 to the left. I want to see your foci drawn. And then your equation of the foci, your coordinates, are a -2 plus or minus the square root of 13, and then up 1, because you're starting from your center and going right and left, the square root of 13. And since being you can't simplify that anymore, that's okay to leave those as your coordinates of your foci. Then we're going to sketch our hyperbola. Make sure you start on the box and not on the foci. The vertices are on the box. Example 4. Because this is addition, this is an ellipse. And because the larger squared value is underneath the x, we are going to have an ellipse that has a horizontal major axis. And from the center to an endpoint is a units. The length of the major axis is 2a, and the value of a is 5. A squared is your 25. A squared is always your larger on an ellipse. Not true on a hyperbola, but it is true on an ellipse. And then your b squared value is 16, so b is 4. And so you go up 4 units to get up to your co-vertice on the ellipse. And so your vertices on this ellipse, well, I guess I should state the center first. The center is -3 and up 2. And whatever's underneath your x, the square root of that is how far you go right or left. So from the center, we're going 5 to the right and 5 to the left. Whatever is underneath your y, from the center, you're going to go up the square root of that. So it's 16 squared, it's 4. So from the center, go up 4, that's a co-vertice, and down 4, that's a co-vertice. And so your ellipse looks something like that. And I need to find the vertices. And to do that, we're taking -3 and going right and left 5. You can't leave your answer like that. You need to simplify. So that's where you get 2, 2, and -8, 2. So those are your vertices. Your co-vertices, you are taking the center and you're going up and down b units. So you get -3, 6, and -3, -2. And those are your co-vertices. And so you still need your foci. And to do that, you need the value of c. And so you need to have memorized that c squared is a squared minus b squared. It is that larger value in the denominator minus a smaller squared value. And so we're getting c is 3. And so again, you need to go right and left from the center 3 units. So those points become 0, 2, and -6, 2. And I want to see those plotted. Example 5. Write an equation of the parabola whose vertex is at 3, 2 and focus is at 5, 2. Well, I find it that I need to sketch it out to kind of choose which equation of the parabola to use, whether it's a y squared or an x squared. And so if I go to the right 3 and up 2, that's a vertex. And if I go to the right 5 and up 2, that's a focus. That tells me that it's opening to the right because the focus is going to be inside the parabola. And when it opens up right or left, it is a y squared. So it is, x equals 1 over 4p. All right, y minus, its k goes with the y. And the h will be on the outside. So you need to figure out the value of the 4p. I mean, right now, you should be able to put in the h and the k because right here, 3, 2 is h comma k. You have to be careful. The y coordinate goes with the y, so it's a y minus 2, and the x coordinate then in this case will be on the outside. So that's taken care of, but now you need to figure out 4p. Well, because it opens to the right, p is positive, and the distance between the vertex and the focus is p units. So p is a positive 2. That means 4p is 8, and your equation is this. And I am good with that. I think because of the way the textbook gave the equations, they are going to subtract the 3, multiply by the 8, and leave it 8 times the quantity. Oh, come on. And then they will write the squared term on the left and the 8 times x minus 3 on the right. That fits the form that they gave us in the notes. So you might have to rearrange yours to check your answer with the back. I'm okay with either form. Write the equation of ellipse with the foci at 2, 3, and 6, 3. So to the right, 2 and up 3, and then 3, 4, 5, 6, and up 3. These are foci. The foci are always on the major axis, so that tells me we have a horizontal major axis. And the center, the midpoint of those foci, which you should be able to just eyeball, but you could also average the foci. 2 plus 6 divided by 3, and 3 plus 3 divided by, divided by 3, sorry, divided by 2. And come up with, they're going to be at 4, 3, but you can just see that. That is going to be your center. It also tells you that the value of c, because the distance between the foci is 2c, or the distance from the center to a foci is the value of c, that c is 2. And then when they give you that the co-vertices are at 4, 1 and 4, 5, the distance between the co-vertices is 2b, so b is 2, because from at 3 to get up to 5, it's 2 units away. So b in this case happens to be 2. And so for the equation of the ellipse, we need a. And for on an ellipse, it is c squared is a squared minus b squared. So we have 4 is a squared minus 4, or a squared is 8. So in my equation, it is going to be x minus 4, because we use the center here, and a squared is 8. And then we have y minus 3 squared. And that's over your b squared. B is 2, so that's your 4, equals 1. And that is your equation of your ellipse. Write an equation of a parabola whose vertex is at 4, -2, and focus is 4, 3. So this is the vertex. Focus is at 4, up 3. That tells me we have a parabola opening up. And so that is a y is equal to 1 over 4p x minus h squared plus k. P is positive, and the distance from the focus to the vertex is the value of p, and that distance is 5. So 4p is 20. And the vertex is right here. This is my hk. So my equation is y equals 1 over 20 and x minus 4 squared, and then minus 2. Number 8, write an equation of a hyperbola with vertices at -6, 4 and 2, 4. So there's negative, oops, I didn't go -6, sorry. So -6, 4 and 2, 4, those are vertices. So that tells me it's opening to the right and to the left. And foci are at -7, 4 and at 3, 4. So the center of this has to be at the midpoint of the vertices. And you get -2, 4. That is my center. And because it opens to the right and the left, I know it is, the y is going to be negative, and the x is going to be positive. You have to memorize that. And so I need to find the values of a and b. Well, the distance between the vertices is 2a. And 2a, the distance between vertices is 8, so a is 4. So a squared is 16. And then the distance from the center to the focus is your value of c. So c from the center, we're at -2 and we're going to 3. C is 5, so c squared is 25. And on a hyperbola, a squared plus b squared is c squared. So we have 16 plus b squared equals 25. So b squared is 9. So my equation, using the center for hk, x plus 2 squared over my a squared value of 16 minus y minus 4 squared over my b squared value equals 1. There's a lot to sort out, and start getting them sorted with all the things thrown in together and getting prepared for the unit test.